Okay, so in this video, we are going to discuss the nomenclature of alkanes. So, first of all, let us see what are alkanes. Alkanes are hydrocarbons, and hydrocarbons are those compounds which are composed of carbon backbone. Like this, the backbone, the central position will be occupied by carbon atoms, covalently bonded with hydrogen atoms. And to satisfy the valency of carbon, as you guys know, that carbon can maximum make 4 bonds. So, to satisfy those valencies, hydrogen atoms are present there, and the bonds are covalent. These are saturated. It means all the carbon hydrogen bonds are must be single. This is carbon and this is hydrogen. It is bonded to 4 sides, and all these bonds are like these are the saturated bonds. The carbon carbon and the carbon hydrogen, these bonds are saturated bonds. General formula CnH2n plus 2. It means if the carbon number are 3, 1, 2, and 3, and we place 3 in place of like n, 3 twos are 6, 6 plus 2, 8. It means for an alkane having carbon number 3, the number of hydrogen will be 8. We can calculate it from here. 1, 2, 3 carbons. 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. C3H8. And this is propane. Some common examples of alkanes are methane, it has 1 carbon, ethane with 2 carbons, propane 3 carbons, so on, heptane with 7 carbons, and decane with 10 carbon atoms. So what are the parts of an IUPAC name? There are 3 main parts of an IUPAC name. You have a prefix, it means it comes first. It could be a substituent. Usually it's an alkyl substituent, either a methyl group, propyl group, or like butyl group. And then root or stem name. Root or stem name means the number of carbon atoms apart from substituent. Apart from substituent, how many carbons are there in the chain? If there are 2, that could be ethane, 3, 4, and so on. Suffix. Suffix is the last part of the name, and it tells us about the class of compound. Either it's an alkane, alkyne, alcohol, and so on. Let's move on to detail on that. So these are some common prefixes. I told you previously that prefixes are supposed to be usually, not all the time. They are the substituents like methyl, ethyl, propyl, and butyl groups. Stem means the number of carbon atoms in the chain apart from the substituents. And eth, if there are 2, it is eth. If there are 4, it's but. And if there are 6 carbons, it's hex. And then suffix, it could be ane, ene, ine. If all the bonds are saturated, it's ane. If there is at least 1 carbon-carbon double bond, it's ene. And if there is 1 carbon-carbon triple bond, then it's ine. Okay, so stem names, these are some common stem names. For 1 carbon chain, it's meth, 2 carbon chain, eth, 3 carbon prop, 6 carbons hex, 8 carbons oct, 9 carbons non, and 10 carbons dec. So this is how we may have an idea. If we somehow memorize these stem names and the common prefixes and the suffixes, then these will help you out in further naming that organic compound or any like hydrocarbon. These are some common rules. I have separated these rules into like 5 points. First of all, you need to identify the longest continuous chain. Again, this chain does not include any substituents. Substituents are added as prefixes. So identify the longest continuous chain of carbon atoms. Secondly, identify the name and location of the substituent on carbon chain. Either it's ethyl, methyl, propyl. Location means on which carbon it's present. On carbon number 2, carbon number 3, carbon 4, on which carbon it is actually present. And then if there are more than 1 substituents, then analyze whether they are similar or different. It means if there are two substituents, analyze whether both of them are methyl or both of them are ethyl. So if the substituents are same, we use the prefixes as di and tri, di for 2 and tri for 3. And if the substituents are different, like one group is ethyl group and the second group is methyl group, then we must name them in alphabetical order. For ethyl and methyl, the E comes first, so ethyl substituent will be placed before the methyl substituent. So this is an example. This is a simple alkane or a hydrocarbon, a saturated hydrocarbon. These are the same structures, and these are the two possibilities of identify the longest continuous chain. So this is possibility number 1. We are going to identify the longest continuous chain, a chain with 5 carbons, and the second continuous chain is this, okay, and this is with 3 carbons. So it's apparent then the longest continuous chain is the first one, and in the next slides I'm going to go with that. And why do I have numbered from this side? Because we have to number. So I am going to go with this chain, and we were discussing that the numberings will be started from this side because the substituent is closer to the end. And if we start numbering from this side, like 1, 2, 3, 4, it will get the number 4, which is the highest number. And according to rules, we want to give our substituent the lowest number. So the numbering will start from this side. Okay, now let's break me down it into segments. So identify the longest continuous chain. This is pentane. How? The 5 carbon alkane, this is termed as pentane. And then we have identify the substituent. Identify it. Okay, this is CH3. This is methyl group, and it is present on carbon number 2. It's the name and the position of the substituent on the longest continuous carbon chain. Okay, now we have to number the substituent or find the location of the substituent on the chain. Okay, fine. Then always give lowest number to the substituent. In this case, it will be 2. So the name is 2-methyl pentane. This is 2-methyl pentane. Here, here 2-methyl, it is your prefix. Pent is your root or stem name. Ane, this is your suffix, the class of the compound. Okay, if we have two same substituents, then if there are more than one substituents and both of them are similar, then before the name of the substituent, di, tri or tetra prefixes are used. Let's look into this examples. Okay, so the numbering will start from this side, closer to the substituent. 1, 2, 3, 4, 5. It's a 5 carbon chain. It's pentane, and it has 1, 2 methyl groups. Two substituents at the same carbon, carbon number 2. So this is 2,2-dimethyl. Okay, the prefix will be 2, 2. 2 methyl groups, both at the same carbon. Dimethyl, 2-methyl. Root name will be pent and suffix will be ane. So its IUPAC name will be 2,2-dimethyl propane. Sorry, 2,2-dimethyl pentane. It will be like pentane over here. Okay, so this is not propane, this is pentane. This is the pent chain. Maybe I have made the other example, so I just forgot to quote it over here. Fine. Okay. Okay, next we will be moving towards naming two different substituents. So if there are more than one substituents and they're different, okay, different means one could be ethyl, the other could be methyl, then they are placed alphabetically. So this is the longest continuous chain. This chain is the longest continuous chain. This chain could not be the longest continuous because this is 1 carbon, 2 carbon, 3 carbon, 4, 5 and 6 carbon, and this is the 7 carbon chain. So this is the longest continuous chain. It is heptane. Okay, and the substituents we will start numbering from this side. So this is first substituent on the chain. This is the methyl group. Okay, it's somehow branched, somehow tilted, and it's fine. It's a substituent. This is 1,
at position number 2 and the second substituent ethyl group at position number 4. So basically ethyl is at 4 and methyl at 2, but alphabetically we have to place ethyl first and then methyl. So it will be 4 ethyl 2 methyl heptane. IUPAC name 4 ethyl 2 methyl, and this is a 7 carbon chain, 7 carbon alkane chain. So this is heptane. Yeah, heptane. These are practice questions for you. Draw the structural formula of 2,2,4 trimethyl hexane. Go retro. And this time, apart from name, you have to deduce the structure from the given name, and you can do it. Name the following hydrocarbon. You have to first of all identify the longest chain, and then identify the substituents and their position on the chain, and then name it. And you can like write their answers in the comment section below, or maybe contact me in person.